Welcome back to some more geometry. Let me turn this off real quick. Today, we are talking about proving lines relationships. So let's kind of go over a couple postulates and theorems that kind of help us prove that information right there. So starting with the angle addition postulate, as we've spoken before, similar to the segment addition postulate, angle addition says that I can take two smaller angles and put them together to create one new big angle. Now, that also works the opposite way. What if I have a big angle and I know there's two smaller angles in there? Like, oh, well, I can split it back to two smaller angles as well, as long as I know I have a segment going from the vertex right there. So angle addition, you can combine them to make a new one, or you can separate them. Knowing you have two smaller ones to the big one, you can separate as well. As we'll have a practice problem with that later. Now, the way we will see in the homework as well is similarly like this. Like, hey, I know that angle 2 right here is 56 degrees. And I also know the entire angle JKL, the whole thing right here, is 145. The question is, what is angle 1? Well, you've used this before. The way you would do it is like, well, if I know the whole thing's 145 degrees, and I know that part of it is 54, then which is use Gödel's subtraction. In doing so, we're left with, what do we get right there? 5, 6, 7, 8, 9, 10, 11, 12, 13, 30. Yep. 89 degrees. Hopefully that, and that right there is how you will see this in the assignment, but as well as combine them. Now, a couple other theorems that we'll be supporting, that we'll be using to support today is the segment addition. The supplement theorem and the complement theorem. They work the same way, but let's talk about them separately. So the supplement theorem is when you have two angles are in a linear pair. You know for sure they're in a linear pair. Then you can go ahead and make the assumption that they are supplementary. So you're just making assumptions here. Like this theorem lets us go ahead and say, hey, since I know these are a linear pair, then I can go and say they're 180 degrees, and I can go ahead and say they are supplementary angles. So that's the thing. The if part is like, I know I have two angles, and they happen to be a linear pair. Then I can go ahead and say they're supplementary angles. And we're like, oh, that's pretty obvious. Of course they are. We've done this before already. Well, yes, but now you have a theorem that supports it. So when you're doing a two-column proof and you go ahead and say, hey, angle 2 plus angle 1 equals 180, you say, well, what lets you say that? Oh, the supplement theorem does. The supplement theorem lets us say that. Same thing with the complement theorem. Now, the complement theorem, and I was talking with this class earlier, with the complement theorem, you have to know that the two rays on the outside, so this ray, as it says, the two non-common sides, that they form a right angle. Now, if I know I have a right angle and then I have angles inside, then I can go ahead and say, oh, those two angles are complementary angles. They equal 90. So same thing. Like, how do I know angle 2 plus angle 1 equals 90? Oh, because the complement theorem says that if I know that's a right angle, then I can go and say they equal 90 for sure. Now, how that differs from the congruent supplement theorem and the congruent complement theorem, that's a good question. So let's talk about that. So let's break down the information. So congruent means they're equal. They're the same, congruent. Supplement, that means they equal 180. So somewhere along the way, we're talking about angles that equal 180, but then also congruent. Are we talking about like the same angle? No. So what this theorem is saying is that if I have one angle, let's take angle 1 right here, and I add that to angle 2 right here, they equal 180 degrees. All right. I also have that same angle 1 right here, and I'm going to add that to this angle 3. So put these two together, and they give me 180 degrees. So I have two separate different angles that give me the same sum with the same one angle they share in common. So what's the relationship of angle 2 and 3? That's a good question. They have to be congruent. They have to be the same. So for example, if angle 1 is 80, the only way 80 plus some angle equals 180 is if this is 100. Well, if that same 80 is added to another angle and I get the same amount, 180, then these two have to be the same amount. Okay, so that's what the congruent supplement theorem is. Two different angles are supplement with the same one angle, then those two angles have to be congruent. The congruent complement theorem works the same way. If I have two separate angles, so 1 and 2 together give me 90 degrees, and 2 and 3 give me 90 degrees, then the relationship of 1 and 3 is they are congruent. They have to be the same. All right. now, some of vertical angles. We talked about vertical angles before, what they are. So understand, vertical angles is speaking of, when you say these are vertical angles, you're speaking about the position of them. Okay, so angle 4 and angle 2, they're vertical angles because they're the only thing they share is the vertex, and they're across from each other, and they're formed by two lines intersecting. Correct? Correct. And then we got angle 1 and angle 3. They are vertical angles as well. They're across from each other. They share their vertex, and they're formed by two intersecting lines. Now, this theorem, which we already talked about before, but we have an actual theorem name. The vertical angle theorem says if you know they're vertical angles, then they are congruent for sure. They are equal to each other, both in size, as far as like how big they are, wide, and also amount. Once we know the degrees, also in degrees as well. All right. So a couple things else to cover up that kind of go all together. The right angle theorem says a lot of things. It says many things. So it says these three right here says that, hey, if I know that I have two perpendicular lines right here that intersect, then they will create four right angles. So that's the first part of the right angle theorem. The right angle theorem also says that all right angles are the same. So when you're working a two-column proof and they say, hey, how can I assume angle 1 plus angle, or angle 1 and angle 2 are congruent? Or like, oh, well, the right angle theorem says if I know these are right angles, then they are congruent for sure. So I can go ahead and make that assumption. So right angle theorem. Okay, perpendicular lines not only do that as well, but when you have perpendicular lines, the angles next to each other, so the adjacent angles, they are also congruent. So now is only 1 and 4 congruent by vertical angles, 1 and 2 are congruent by the right angle theorem, and not only is all of them congruent to each other as well, but of course the neighboring angles. All right, so the last couple things that kind of derive from that right there is you know that you have two angles that are congruent in supplement. So these two angles, when I add them up, equal 180 degrees. And I also know that angle 1 plus angle 1 is congruent. So let me rewrite this. Angle 1 is congruent to angle 2. So if I know angle 1 and angle 2 are congruent, and angle 1 and angle 2 equal 180, then these have to be right angles. It's the only way that works out. And I also know if I have a linear pair and they're congruent, they're also right angles. So I know these are congruent, and I know they're a linear pair because, again, they're on the same line, split by a ray, and they happen to be congruent to each other. So that means they also have to be right angles. So those are the new theories and postulates that we covered today to kind of help us with our proofs. And we're going to do 3 proofs to kind of support that right there. So let's start with the first one. So on this proof, they tell us that, hey, our given is that ABD, so this angle right here that's kind of slanted, the two angles together form a right angle. Okay, and then DBC, these two right here, also form a right angle. So if you look at this, they both share this right here. So the question is, how can we prove that ABD, this little angle over here, and EBC, this angle over here, they are congruent? Can we prove that? Well, let's see. So we'll start with the given information. We write that down. ABE, DBC, they are right angles because that's what is stated. Now, based off that, according to the definition of right angles or the right angle theorem as well, you can go and say that, hey, they're 90 degrees. Ooh, so we know for sure those are 90 degrees. So things that are 90 degrees, as we said earlier, if they're 90 degrees, then they are complementary. If you don't remember which one that was the first one of the first ones we covered. The complement theorem says if you know that the angles are in a right angle, then they are complementary angles. So as we see up here in our problem, angle ABD and DBC, so these two angles right here, they are complementary because they equal 90. And then this angle right here, DBE and EBC, they are right angles. That's our complement theorem. Complement theorem. That's shorthand for complement, shorthand for theorem. Okay, now this is where the magic happens. So if you look at this, we say, hey, ABD, so this angle, and DBE, they make 90 degrees. So this angle and this angle make 90 degrees. Well, then that same angle makes 90 degrees with a whole another angle. So kind of going back to the angle 1 plus angle 2 business, and then angle 2 plus angle 3 right here. If I know that two separate angles make 90 degrees with the same one angle, then what was the relationship to each other? They were congruent. By which theorem? This is the congruent complement theorem. Complement theorem. That's what proves that these two angles way out here are congruent, but the congruent complement theorem. But what we had to state is this part. We had to state that they were complementary, or even this, if we were to break it apart. Here they said the whole thing is 90, but we broke it apart right here by saying that they are complementary to each other. So by saying, this is probably the most important step, is we had to say that the two individual angles make 90, and then that one angle with a whole different angle makes 90. By saying that they're complementary angles, then we go ahead and make the connection between these two angles right here. All right, that's the first one. Next one, hopefully you take a pause, do it yourself, and if you don't remember, well, let's do it together. So what do we know? So the things we know, we're going to do in red. The thing we know for sure is that angle 1 and angle 2 are vertical angles, for sure. We'll make some assumptions based off that. Now, angle 1 equals D minus 32, and angle 2 equals 175 minus 2D. Okay, that's for sure is all given. So we're going to write that here in the given right here, that angle 1, angle 2 are vertical angles, so vertical angles. And we're going to write that angle 1 equals D minus 32, and of course, angle 2 equals the 175 minus 2D. Now, what lets us say that? Given information. Good job. It's given information. So what can we make, what assumptions can we make based off this? And they're not assumptions. They're what we call the next step. What's the next step we can say? So if angle 1, angle 2 are vertical, then angle 1 is congruent or equal. We're going to say congruent to angle 2. That's based off our vertical angle theorem that we just spoke about theorem. Vertical angle theorem. So we know congruent. So, but we eventually want to find, again, the question is, what is the actual number value of angle 1 and what's the measurement of angle 2? We want to know the actual measurement. So we're going to eventually find an equal. So we're going to switch these to equal. What allows us to switch angle 1 equal to angle 2? Hopefully you remember for the first half of this homework, but that's just our definition of congruency. Now we just said definition of congruency. The book will say definition of congruent angles as well. So definition of congruent angles or definition of congruency, it's the same thing. Definition of congruency is just like the umbrella that covers everything, but then it breaks down segment, angles, shapes. Definition of congruency just covers multiple things. So it's a lot easier to just say that. Now that I know that these are for sure equal, especially the word equal right there in the middle, I can go ahead and start setting it up. Like, okay, well, remember D angle 1 is equal to D minus 32, and angle 2 is equal to 175 minus 2D. I set up an equation because the equation is going to help me find the value of this D right here to plug it back in there. So I have this equation set. Now, what did I just do? I had an angle 1, but now I have D minus 32, and I had an angle 2, and now I have a 175 minus 2D. What happened? Well, we just substituted. We substituted the information we already had in the given to create our equation. I'm going to expand this. Going to need a little bit of room right here. All right. So now that I have this, let's actually work the problem out. So physically speaking, like I'm going to go ahead and, I'm going to do this in blue right here. I'm quote unquote adding 2D to both sides. So if I'm going to do that, the final result is 3D minus 32 equals 175. And how did I get that? Well, like we just said, I added, or addition property. Addition property. Now, I need to get 3D by itself, so I'm going to add 32 to both sides. So step 6 will be 3D equals 207. That again was another addition property. It's okay to use the same thing multiple times. There's nothing wrong with that. Now to get the value D by itself, what do I do? Well, I'm going to divide. I get D to equal 69. So that's division. Ooh, I don't know why I put an S. Division property. Now the question though is not what is the value of the variable D, is what's the measurement of angle 1 and angle 2. So to do so, we gotta plug that back in. And again, what's the fancy math word for plugging things back in? Minus 32. It is substitution. That's how we get the final answer. We substitute the value back in there, which gives us, what do we say? Oh, 37. Now, you can do it all the same line. You can make another line, say number 9 be angle 2 equals 175 minus 2 times 69. You can do that, or you can do the same one like I am. Again, should give us the same value. It's 37. So 37 is the answer for that one. All right, last one. Go ahead and make sure you pause. Try to kind of think about it yourself and figure it out. But if you didn't, well, let's pay attention here. So let's look at our given information. We know that 4 and 7 are congruent. The goal is to say 5 over here and 6 over here are congruent to each other. So let's look at the given information. They told us just that 4 and 7 are congruent. Now, why is 5 and 4 congruent and 7 and 6? What lets us say that information? Well, again, our vertical angle theorem. Angle theorem. Or if you also say definition of vertical angles, I'll take that as well, because you get the idea. Because they're vertical angles, we can say that they are congruent for sure. So now, knowing that 4 and 7 are the same, and then 5 and 4 are the same, what led us to say this right here? What happened? What did we physically do? We literally changed out angle 4 for angle 7, knowing this, or we substituted. You can argue possibly that it's transversal. It's just said not in the right order. So transitive property kind of will work, but not really, I think, in this case. But then what I do one more time, I change that out, knowing that angle 6 and angle 7 are congruent to each other. I substitute that out to get the final answer. Hopefully that helps, and y'all have a great day. Bye.